We can also multiply one matrix by another matrix. So this is an example of multiplication of two 3x3 matrices, and the outcome is that we have another 3x3 matrix which is formed by the corresponding multiplication of row components by column components, and then we add them together to create new components for the resulting 3x3 matrix. So for example, this last element right here is formed by multiplying the corresponding components of the column and the row of the initial two matrices. Similarly, we can multiply 4x4 matrices, and very similar recipe can be applied for this 4x4 matrix multiplication. What's really important to remember is because we are multiplying components of the row in the first matrix by components of the column in the second matrix, the order of multiplication here really matters. A times B does not equal B times A. Likewise, when we apply matrix multiplication to a vector, the order matters. And once again, it is because we have to distinguish the rows and columns when we're forming these results in the matrix that we produce. If you're wondering why this topic is important, it is because when we have multiple transformations, like for example, we can generate a scaling matrix, we can then generate a rotation matrix, we can also generate a translation matrix, and then we can multiply them together. And the result of this multiplication will produce the transformation matrix, which will accumulate all of the manipulations that we already prepared in these matrices. So now this single matrix accumulates all three: scaling, rotation, and translation. And now if we have our original geometry, like a cube shape or something else, modeled somewhere close to the origin of the system of coordinates, like this. And then we take this shape, this geometry, and apply this transformation matrix to every vertex. Right? So we have these vertices V over here, and we multiply V by this matrix. The outcome is that this entire shape, the original object, will be transformed accordingly to these requests, and it will rotate, and it will move, and it will scale by simply multiplying every vertex by the single matrix which now accumulates all other transformations. And every vertex will end up in its new location. Right? So this will be transformation, which will move every vertex to this new position, and so forth. And this is what's typically happening inside a vertex shader program that runs in graphics hardware and executes for every vertex in our original geometry.